Most of the code we write, it just runs from top to bottom, one command after the next. But what if we could give it a brain? What if we could actually teach it to think? Well, that's exactly what we're going to do today. We are diving into decision-making in Python, giving our programs the power to choose their own path. So that really is the million-dollar question, isn't it? How do we get a program to choose its own adventure? We don't want it just blindly following a script. We need it to react, to adapt to whatever we throw at it, and carve out its own unique path every single time it runs. Okay, so think about it like this. By default, a Python program is just a super simple recipe. You follow step 1, then step 2, then step 3. No questions asked. But what if your recipe needs to be a little smarter? Like, what if it needs different instructions for a gas oven versus an electric one? All of a sudden, that rigid step-by-step process just doesn't cut it anymore. We need to give it the power of choice. And this whole idea, this order of execution, there's a name for it. It's called control flow. And today, we are going to grab that control flow by the reins. We're taking that predictable, straight line, and we're going to twist it into a dynamic path, one that's full of forks in the road, choices, and all sorts of different outcomes. All right, let's get into it. Our very first tool, the most basic, fundamental one, is the if statement. This is how we create that very first fork in the road for our code. So, the logic here is super simple. The if statement just asks a basic yes or no question, or in programming terms, a true or false question. If the answer is true, it runs a specific chunk of code. But if it's false, it does, absolutely nothing. It just skips that code and moves right along. It's kind of like saying, hey, if it's raining, grab an umbrella. If it's sunny, you just ignore that thought completely and walk out the door, right? Same idea. And this flowchart right here, it breaks it down perfectly. You see the program flow comes down and hits that diamond shape, the Boolean expression. And don't let the fancy term fool you. A Boolean expression is just a question that has to be answered with either true or false. Simple stuff like, is it raining, or is this number bigger than 10? If the answer is true, bam, the program follows that path and runs the code in the box. But if it's false, look at that. The path just goes right around the box, bypassing it completely. Okay, let's talk about the actual code, the syntax. It's pretty straightforward. You have the word if, then your condition, and then, and this is super important, a colon. That colon and the indented block of code that comes right after it, they are absolutely crucial in Python. That indentation is literally how Python knows which instructions belong to that if statement. Get it wrong and your code just won't work. So a simple if is great for a do this or do nothing kind of deal. But what about when do nothing isn't an option? What if you need a do this or do that scenario? You need an alternative action when the condition is false. For that, we need to bring in its partner, else. Okay, check this out. On the left, you've got our basic if statement that we just talked about. But on the right, see that? We've added the else clause. Now we have a specific, dedicated block of code that runs only when that if condition turns out to be false. This gives us a true this or that choice. One or the other is gonna happen, guaranteed. And this new flowchart really shows the logic in action. See how after that decision diamond, the path splits into two distinct branches? There are no more bypasses. You've got one path for true and a completely separate one for false. Your program is now guaranteed to follow one of these two paths before they eventually meet up again. All right, let's ground this in a real-world example. Imagine you're writing a program to calculate a salesperson's salary. And the rules are simple. If they hit a sales target of, say, 100,000 rupees, they get the awesome benefits package in column 1. But if they fall short, they get the standard package in column 2. This is the perfect job for an if-else statement. And look how cleanly we can translate those business rules right into Python code. We just ask the question, if sales is greater than 100,000, if that's true, we run all the calculations from column 1. Else, which means if sales were anything less than 100,000, we use the rules from column 2. It's a perfect one-to-one mapping from the problem to the solution. Okay, so if-else is great for two choices. But what happens when life gives you more than two options? Think about assigning grades based on a percentage. You might have distinction, first class, second class, fail. A simple this or that if-else just isn't going to cut it. For this, we need to level up to the if-elif-else ladder. So here's the deal with the ladder logic. It's all about order. Python starts at the top and checks the first if condition. If it's true, it runs that code, and then, and this is the most important part, it completely jumps off the ladder. It skips everything else. But if it's false, it just moves down to the next rung, the first elif, which is just short for else if, and checks that one. This goes on until it finds a true condition. And that little else at the very bottom, that's just our safety net. It only runs if every single condition above it was false. So here's that grading logic in action. First, we check, is the percentage 90 or more? If not, okay, let's check if it's 60 or more. If not that, then we check 50 and so on down the line. It's a super clean and efficient way to handle a bunch of options where only one can be true.
All right, for our last concept, I've got a little pro tip for you. For those really simple if-else choices, Python gives us this really slick one-line shortcut that makes your code look so much cleaner. It's called the conditional expression.
And I mean, just look at the difference here. It's night and day. On the left, you've got your standard 4-line if-else block. Totally fine. But on the right, the exact same logic packed into one clean, readable line. Now, the structure is a little flipped, so pay attention. You put the true result first, then your if condition, and then the else result at the very end. Let's make that crystal clear with a super simple example. Say we just want to find the smaller of two numbers. We can just write it out like this. The minimum value is num1 if num1 is less than num2, otherwise it's num2. See how that reads almost like a normal English sentence? That's what makes it so awesome. Okay, so let's do a quick recap. This simple if is for a single choice. Do it or don't. If else is your go-to for a two-way street. Do this or do that. The if-elif-else ladder is for when you've got a whole menu of choices. And finally, the conditional expression is that clean, elegant shortcut for your simple if-else cases. Got it? Good.
And that's pretty much the whole shebang. You now have the fundamental building blocks to give your code a mind of its own. So I'll leave you with this question. Now that your code can actually think and decide for itself, what amazing things are you going to build with it?